Okay, so this is Mrs. Gilbert. I am going to briefly go over dosage calculations and the multiple formats of what ways to perform calculations. So with dosage calculations, the steps, regardless of the formula that you use, which I'll get into in a few moments, regardless, you're going to need to go through these steps. So what do you need? What kind of units is the question asking you for the end product versus what you're starting with? What is the order? What does the order say? What is left on the paper? So there may be information in the order that you don't need. What conversions do you need to use? Does the order give it to you in milligrams, but the vial is in grams or micrograms? There may be a need of a conversion between your steps. And then finally, you can solve the problem depending on the variation of formula that you would like based on your preference. And then finally, you're going to write out the answer appropriately. So make sure that you're not using any leading zero, only use a leading zero, but never a trailing zero. And then is it in the right conversion? Is it in the right unit? Are you giving milliliters when it asked for milligrams? Are you giving milligrams when it asked for grams? Things like that. So then check your answer is going to be the last step to make sure it makes sense with your question. You can kind of do this in a backwards dosage calculation way. So, preferences versus appropriateness. There's three different methods of dosage calculations. There's the formula method, ratio proportion, and dimensional analysis. Now, dimensional analysis is going to be common with like conversion factors, but there are some, like when we get later on into other types of dosage calculations, that the dimensional analysis is not quite appropriate at that time. So just be mindful that it might benefit you now to use the dimensional analysis for right now with these types of problems, but when we get into other types of problems, you may need to know the other kind of formulas. So the first formula method is going to be the desired over have times vehicle. So when you're looking at your order, you're going to look at what is the order desiring from me? What do we have? And then what vehicle? Vehicle is usually like the milliliters, whatever it comes in. Tablets, half tablets, milliliters. Is it in per 1 milliliter or is it per 10 milliliters? What is the thing that it's giving you? Okay, so the second method is the ratio proportion method. So you're going to take the known and the desired and place them in ratio proportions so that you have what in your vehicle, and this should be equivalent to your desired, and you're finding the X. So we'll see an example of this. I'm going to do the same problem in all three ways in just a moment. So the third way is dimensional analysis method. So you're going to take what you want and take what you know. And you'll see how here on the bottom you're going to cross off the things that are similar. This is very common for that conversion factors that I talked about just a moment ago, how taking what you know to convert it to the right unit at the end. So if you need, say, pounds here, how are you going to get there? So we're going to use a lot of conversions in all three methods. So you're going to need to know most of these conversions. These are the common ones. Milliliters and cc's are equivalent to the same things. Some text will refer to it as milliliters, some will call them cc's. Most current and updated knowledge is focusing on milliliters. So but for old school methods, there are still that will say cc's. So that's one of the major ones. Of course, micrograms to milligrams to grams are another one. Teaspoons and tablespoons, and then your kilograms to pounds are going to be the major ones used in dosage calculation. So we're going to take this problem and solve it in all three methods. First is going to be the formula method. Formula method is going to be your desire over half times vehicle. This is my favorite one. It's going to be used most often in class. So first we need to determine what is our desire, what is our half, and what is our vehicle. Our desire is always going to be what's in our order. We desire what is in our order. So our order wants 2 milligrams. Our have is what we have on hand in our vial, in our pill form, whatever it is. So what we have is 1 milligram, but that 1 milligram comes in a vehicle of 1 milliliter. In other problems, it may be in a tablet, such forth, or in 5 milliliters, in 10 milliliters. The volume may change in the vehicle as well. So then setting this up like our formula here, we have our desire 2 milligrams over 1 milligram times 1 milliliter. Our milligrams units are going to cross out. Doing 2 divided by 1 is 2 times 1 is 2. And we're left with only units of milliliters, which is exactly what our problem asks us for, is in milliliters. So we have no conversions left to do at this point. And we are done with our problem. Next is going to be doing the same problem with ratio proportion. So ratio proportion takes our have to our vehicle, should be equivalent to our desire and our x. So our have is 1 milligram, and that is in a vehicle of 1 milliliter. That's our ratio, and it should be equal to our desire, which is 2 milligrams over x. So we're going to cross multiply, and what we're going to get is 1 milligram x equals 2 milligrams times 1 milliliter, and we're going to get divide, solve for x, so it's all on one side. Here our milligrams are going to cross out. We're only going to be left with milliliters, and again 2 divided by 1 times 1 is 2. Okay. Lastly, we're going to do the same problem in dimensional analysis. Dimensional analysis sets it up so that the units are opposite from each other so that they cross out. So again, this is the easiest way for conversions. I'll show you. So we have already one dimension here already set up for us. So I'm going to start there. I like to start there so I don't have to worry about where my x is. 1 milligram over 1 milliliter times, and we're going to need our milligrams on the bottom from our desire. So that these milligrams will always cross out, which means I have an x here because I don't know how many milliliters that's going to be. Now, if this was given to us in tablespoons or anything else, then we could continue to use our dimensional analysis to convert us all the way through in the same thing so that all of our units cross out to where we're left with milliliters. But this problem doesn't need any conversion, but that's how you can keep going. So then here we're going to have milliliters left over is our only unit again. And we have 1 divided by 1 is 1 times 2 is 2 milliliters. Okay. That is the method for all of the ways to do dosage calculation. We're going to be going over these in much further detail and examples from your workbooks during your lab. So this was just to introduce you to the different ways and preferences. Again, in lab, I'm going to be focusing more on the desire over have. This seems to be the easiest as we progress through with other problems and other formulas that we can just take from the desire over have times the vehicle and manipulate it just slightly so we're using the same base, if that makes sense. With the other ratio, proportion, dimensional analysis, when we get later into like drop factors and things like that, it's not really using the same formula. You're having to go to use another formula, but so I like to just think of one formula and modify it as needed. But whatever works best for you for right now to get you there also works. Just be mindful of that when we get to more detailed dosage calculations later. You are going to have to do another formula. I will see you all guys later. Email me if you have any questions.